squads? Welcome back. Today we're going to talk about inverse function. It's a very important concept. It comes in many chapters, many lessons. You need this for logs. But today we're just going to talk about what inverse does. Inverse just means undoing. How do we undo a problem? So if I give you, for example, if I give you a problem like this, right? If I go forwards, what are we doing with this x? So we're going to times it by 3. And then you're going to subtract by 1 if I'm going this way. So you times it by 3 and subtract 1. Well, how do you go backwards and then undo it? So example I use is like you're watching film. You're watching, it could be anything, a golf swing, a basketball shot. You play it forward and you watch it and you pause it and then you decide to play it backwards. So what happens, everything has to go, my last step becomes my first step. So instead of minus 1, you're going to add 1. And instead of multiply by 3, you're going to divide by 3. If you do this, it undoes the problem. That's what we're trying to do with inverse functions. There are a lot of key components to this. I'm going to talk about each step. So the first one is writing equations. These are your steps. To write the equation of the inverse, you have 2 steps. Swap x and y, and then solve for y. Okay? Our theme for this video is going to be swap x and y. We're going to swap x and y. You'll see it happen a lot. So if I give you any equation, and I want you to write the inverse, we could write it, so we're going to swap the x and y, and we're going to solve for y. So we're going to add 1, and then divide by 2. So my y, which I'm going to write this -1, that just means inverse, of x is x plus 1 divided by 2. This is the inverse of that function. So my 2 steps, swap x and y, and then solve for y. Graphically, what happens is if I give you a set of points, right, as your f of x, your f inverse of x, all you have to do, once again with that theme, is just swap your x and y. So your inverse, you're just going to swap them. Those are your inverse. So if you graph it, what you'll see is, this is not the actual graph, but if I graph this line like this, let's say I have a line like this, your other line, what's going to happen is, because our theme is swapping x and y, your graph is actually going to reflect at y equals x. Y equals x just means y is equal to x, x is equal to y, so your graph actually reflects there. So that would be the inverse. So graphically, our points swap, and then my equation, my graph reflects at y equals x. Domain and range. Domain and range does the same thing. Domain represents your x value. Your range represents your y value. Right? So what happens, that swaps as well. So this domain becomes your range of your inverse, and your range becomes your domain of the inverse. Right? So for example, if I have this graph at 0, 1, and it's like a half a parabola, and I swap my points, so I get this, and then my graph looks like this. So here's f of x, this is f inverse of x. Well, let's do my domain for f of x. How far left, how far right does this graph go? Good, it goes from 0 to infinity. My range of f of x, how far down, how far up does it go? Well, it goes from 1 to infinity. Because of this guy is 0, 1. All I have to do is swap these guys to get my domain and range for my inverse. But let's do the domain and range for my inverse. What's my domain? How far left, how far right? Yeah, now we're going from 1 to infinity. And then my range of my inverse, I go from 0 to infinity. So what happens is these 2 swap and those 2 swap as well. Because my theme, remember, x, y swap. Domain is x, range is y, so we swap those guys. All right. Last little thing. to determine if the inverse is a function, we have to use the horizontal line test. Right? So if I have a parabola, is this a function? Yes, because it passes the vertical line test. So it is a function. However, is its inverse a function? Well, no, because when I do a horizontal line test, it fails the horizontal line test. So the inverse is not a function, which makes sense because if I graph this guy, the inverse will look like this. And then is this inverse a function? No, because it fails the vertical line test. So vertical line test tells me if a graph is a function, or if an equation is a function. The horizontal line test tells me its inverse, is it a function or not? Okay, that concludes my lesson with inverse functions. Let's get ready for some problems. Good job. All right, our first example, I want you to write me the inverse equation of this function. This is linear. About 30 seconds to a minute. Think of your two rules. Go. All right, let's say, what's my first step? Swap x and y. Second step, solve for y. So I'm going to subtract 3. So you have x minus 3 equals 2y, and then we're going to divide everything by 2. So you have y equals x minus 3 over 2. That is my inverse. Check your answers. Make sure you did your steps correctly. And let's move on to our intermediate problem. Good job. All right, if you have 2/3 x minus 1/3, I want you to write the equation of its inverse. About 30 seconds to a minute. Try your best. Go. All right, step 1, swap x and y and solve for y. So we add 1/3. That's my first step. How do you get rid of this times 2/3? Many kids will say divide by 2/3, but instead of divide, let's multiply. What can we multiply to get rid of this 2/3? It's reciprocal. So we multiply by 3 over 2. And that cancels out. The inverse will be, I won't even distribute it. I'll just leave it like this. I'll just leave it like that. All right, so check your work. See if you did it correctly. Some of you guys might have distributed. It's okay if you did that. So just take one extra step. All right, let's do our advanced problem. Our last problem. Let's say I gave you a problem like this. I want you to find me the inverse equation. All right, I also want you to graph it, the inverse, and I want you to tell me if its inverse has a function. And then also throw in domain and range. So we do all of it. So graph it, write it, domain and range, and is the inverse a function? Okay, I'll give you a minute for this. A big problem. Go. All right, let's see. Let's write it first. So we're going to swap x and y. So we're going to divide by 2 first. You have to outside in, so you divide by 2. How do you get rid of a cube root? You cube both sides. So you have x cubed over 2 times 2 times 2, which is 8. And you're going to add 5. So essentially you have that as my equation. It should be y, sorry. This is my equation. So that's write it. Let's graph it. If you know your rules, this is a cube root. Looks like an S almost. A sideways x cubed graph. So if you graph this, shift to right 5, roughly it's going to look like this. So that's graphing it. The inverse, all you have to do is reflect it here. So your graph probably is going to look like this. At 0, 5. Remember, we swap my points. So this is f inverse or g inverse, and this is g of x. So that's graphing it. Is the inverse a function? Well, if I do the horizontal line test here, it passes everywhere, so yes. And we can tell by your inverse function that if you do the vertical line test, it is true. My last domain and range, my domain of g of x is what? How far left, how far right, all reals. My range of g of x, how far left, or how far down, how far up. Same thing, all reals. So what do we do with my domain and range? I swap them. So my domain of g inverse will be all reals, and then my range of g inverse will also be all reals. Because we swap them. Which makes sense, because here, how far down, how far up, forever down, forever up. How far left, how far right, forever left, forever right. Okay, so these are all your rules. It's a big problem. If you can do this problem, you are ready. Alright, so that concludes my lesson with inverse functions. Make sure you practice these problems and try it again. Hopefully these videos helped you. Please subscribe to my channel. Please turn on your notifications. And let's get ready for some more math videos. Good job.